It's getting recorded, right? I think.
Yeah.
Yeah, okay. So our first question is like r of 2. We are given an integer and we need to write a function to determine whether it is a power of 2 or not. Or it can be like 1, you can write 2 raised to the power 0, and 16 2 raised to the power 4. And for 218, you can't write in a power of 2. So, yeah. So how do you approach here?
So can I share my thought?
Sure,
Sure,
sure.
sure. Go ahead.
Yeah, so basically, if we, okay, can I, maybe it's better just share something. One second. Okay, you guys can see my screen.
Yeah.
Yeah. So basically, they are saying that give whether x is power of 2, right? So basically, like let's say this is my x and this is my power. So 2 raised to power should be x. So we don't know what the power is, but let's say if I give x is 1, then I know that if I do him 2 raised to 0, then he will give me 1. So 1 is, we want to return true for this. So our return is true. Then if we take 2, then if I do power of 1, so then 2 raised to 1 is 2. So we should also return 2 here. Now if we take 3, let's say, then there is no integer power that we can raise to because the next power will come to be 2, right? We already used 1, so only 2 is remaining. So 2 raised to 2 is 4. So I can't basically find. So he is false. And then let's take one more. So if we take him, if we take 4, then if I raise 2 raised to 4, 2 raised to 2, then that will be 4. So that's true. And one little bigger. So if we take 16, then if I raise 2 raised to 4, then 2 into 2 into 2 into 2 is 16. So we should return true. So that's we can see that these are the numbers. So x is the number, and we want to determine whether he is a power of 2 or not. And implicitly, we just check that what should be the power if that were true. If it was a power of 2, what would be the power it would be raised to give x? What would 2 be raised to give x? So x, we have to return true or false. So given x, basically return true or false. That's the goal. So I think one step brute force can be done is we just take from 0, 1 to all the way up to let's assume if we can use square root function, that's fine. Otherwise, maybe we just keep going basically till we reach the square which is greater than the number, right? So keep using powers till 2 raised to power becomes greater than x. So if we, for example, if we wanted to check 4, we would just go like this, like 0. Okay, 2 raised to 0 is 1, so still low. 2 raised to 1 is 2, still lower than 4. 2 raised to 2 is 4. Okay, I have found the match. So then true. And then let's say my number was 3. So then I would have gone 2 raised to 0, 1, still lower than 3. 2 raised to 1, 2, still lower than 3, 2 raised to 2, 4. So now I have exceeded 4. So my 2 raised to the power, which is 2 raised to 2 was 4, which is greater than 3. So now I have exceeded the number. So I will not find a solution now. So that is one way, right? Probably not very efficient. I'm not sure if it will time out or not. I didn't try it. So that's one. But then some little better approach can be, we can look at the bits, right? So we can see that if I look at X and now we try to see what is the binary representation. So X will be, let's just take some digits, like 5 digits, 1, 2, 3, 4, or maybe let me write it here. 1, 2, 3, 4, 5. So that's maybe 1, right? And then 1, 2, 3. So this is 2 in binary. And this is, sorry, this.
No.
This.
00011. Yeah.
Correct. Thank you. Right. And this is 4. And sorry. Yeah. And yeah, 1000 is 8 and 10,000 or 1 and 4 zeros is 16. So we can see this pattern, right? That the last significant digit is, sorry, so this was false, so we don't want, but this is not a good correct case, but this one has the significant digit on first, or what we call significant digit is 1, then everything else is 0 to the left. And there is only one basically. So we can use that property, right? So then basically in the bit representation, we will have only one, and then that 1 appears in the most significant bit position. So these are the two conditions we can kind of exploit. Now, what we can do is just algorithm would be that we can take a mask, which is, let's say, 1. So mask of 1 is basically like all digits and then 1, right? Whatever is the integer size on my computer or my language, everything will be zeros and only 1 will come at the end. Then I can keep let's say I keep a 1 count, like how many ones I have seen. So that will be the way I track how many ones I have seen. And the 1 count is and I can keep my number, right? Whatever is my number. So whatever is my number is given, I can do this. I can keep it. Now I can quickly run a loop. So if we take this guy, right? Let's say 100. So my number is 100, and then I mask him with X. So I will do this and 001, which is my mask. So this will give me 0.
Yeah.
So that means my 1 count is still the same. I'm not increasing. Okay, then I can do a right shift on my number. So I will do number equal to right shift 1. So that means my number will now become 010. So that 1 shifted, right? And then I do I'm just writing little concisely. Yeah. So and I do a mask with 1. So that will still give me 0. So I don't, now I go here, num again 1. So that means num will become 010, 001, right? It was 010, 1 shifted, right? So it will become this. And then I AND him with my mask. So now I get a 1. So now my 1 count will become 1. And then I right shift my number again. So number equal to num 001, number right shift 1, which is I was at 001, and now he will become 000. So now at this point, when he becomes 000, I will exit because now my number has become 0. And at this point, I can check that my one count is 1. That means I will return true. I found one number that is true. So only one count I found. One I found. And so I returned true. And my number has become 0. So what that means is that that one was at the MSB position. Now, very quickly, if we just take a negative case, we'll go through quickly this time. So let's say we take that case, right? 0, 1, 1, which is 3. We know this is not a power. So what we will do is we will first AND him and this number with mask. So we will get 1. Now that means our one count becomes 1 instead from 0, it bumped up to 1. Now I will do my number is right shift bed by 1. So 0, 1. So 0, 1, 1 was that, right? And when I right shift by 0, it will become 0, 0, 1. And then I AND him with this. Now, so this is also 1. So now my one count has become 2. So that is wrong. As soon as it becomes 2, I can exit. And I want to check basically. So so this is wrong. I cannot have 2, 1. So he is not a power of 2. So that's the idea, that we keep going. We keep reducing the number to 0 and we keep checking for ones. And at the end, we should have 2 conditions, that the number should become 0 and the count should be 1. So hope that makes sense.
So you're trying to count all the bits, right?
The one bits.
Yeah, 1 bits. And then if you find any bit, anytime the count more than 1, it means that you are going to return false for this is power of 2, right? Or else you return true. Yeah. Okay.
So every number which is a power of 2 will have only one set bit, right?
One set bit in the MSB.
MSB, yeah, MSB. Yeah, exactly.
Yeah, anywhere, so you know, if you have 1 bit, that's enough, wherever it is.
Wherever it is, yes.
Yeah.
Yeah, just to add to it, actually there is a trick. I mean, it is a simple empirical. So there is a formula n ampersand n minus 1. If it is 0, then either the n is 0. Then either the n is 0 or it is a even number. So that is just a straightforward formula is there. So Jagrita, if you can write.
I was, you're right, Rajendra. So 1 second before I just go to that one.
Okay.
Yeah, that's a good one also. So this one, right? Okay. So if this is clear, then let's move to one more even shorter thing. So what happens is, when we look at this guy, right? Like 8. So he is like this. And when we look at 7, he is actually like this. When we look at 16, he is actually like this. Sorry, 16, he is like this. And when I look at 15, he is like this. So that means that if I do like this 16 minus 15 or 16 into 15 in the binary one, what will happen is they will become 0. So it's like this, right? This is 0 in all the bits except this guy. And then 15 has 0 where there is 1 and then 1 here. So they will nullify basically. So the output will be 0. And this will hold true for all the cases where you have that, because kind of we just saw that all square will have 1 in the MSB. So if I take 1 less, in the binary way, how it will have proceeded is all these guys would have been 1. So there is nothing to bump up here. So the next iteration would have made this one, the significant digit that's coming next as 1, and all these guys would have reset to 0. So using this, right, it will also hold for this, like this is 8 and this is 7. So if we AND them, they will also become 0. So basically, I think this translates to n into n minus 1 equal to 0. Or we may have to check, like if n, I'm not sure, if n is less than equal to 0, then you can return false, else something like this might work. Basically that this. Rajendra, correct me if this is.
N has to be greater than 0, then only n minus 1 you can use.
So n less than equal to 0 is false. So he will be either 1 or bigger than 1, right?
Yeah, I think so. That's right.
So this thing will not work when we are dealing with numbers with big integers. Basically, if it is a 128-bit integer or things, any integer which exceeds the word size of the computer, this formula will not work. So for that, so the initial approach, the linear approach that Jagruth was sharing, that is going to work. Or maybe we can think of a recursive solution. So where we can simply divide by 2 and we'll see left half should be equals to right half. Otherwise it is obviously it is not even number. We didn't start with the even number, right? So like that we can just break down. And so that is one possible thing. So yeah, so for 16 it is 8 and 8. Let's go to 8. And here we can use dynamic programming to capture the this thing so that we don't repeat the computation. And in fact, this is not even a branch out system. Why I should say that is, we know at every stage we are actually looking, one is the mirror of the other, every stage. So what we are saying is 16, there must be 2 8s, otherwise it is false, return false there from there itself. Okay, now we have got both of the sides same. Okay, let's go down one more time. It is 4. Is the left and right both are 4? Yes. Okay, then it's fine. Let's check the 4 and return it. So like that we can go down. So that way we are not even branching out. There is no left and right. The left and right subproblems must be the same size. Only then we'll go and probe further. Otherwise, we can straightforward return false from there. For example, 15, 8 and 7. We know that 8 is not equal to 7. That means we started with an odd number. So let's return false from there.
So Rajendra, is that not the same as like keep dividing by 2 till you, if the remainder is 1 at any point, then just return false. Otherwise, keep dividing by 2 till like you reach 1.
Yes. It looks like that. Yes, correct.
8, 6, 4, then 2,
Basically
and you will reach
divide
1.
And remainder.
Right?
But
like,
yeah. The only difference here will be we are using even basically we are not even using what should I say? Yeah, probably there is no other advantage. Yes, correct. It is the same thing. So one was I was basically bringing a recursive kind of thought process into picture. If you go the remainder way, it is just straight while loop, non-recursive way.
Yeah, that's a good point actually Rajendra brought in, because we really didn't, clarify on the requirements, so that is why actually, because here the problem solution right way, it just talks about nothing like that, right? It doesn't talk about no constraint. Yeah, so it can be any open-ended problem. Right, yeah, good. So this is a good way actually to keep in mind if something comes up like that. Yeah, thanks Rajendra Jagrut. Yeah, that was good.
Yeah. And then this just from code, it's the same. I intentionally kind of put the code up so we could go the algorithm first. But
Sure,
this is
yeah.
same thing what I just described. Same num variable, one variable, mask, and then keep looping till number becomes 0, or the one count. I mean, both these have to be satisfied. So if number is becoming 0 or one count is becoming 2, then break up the loop, and then both these have to be set. Otherwise, we just count the ones and we increase them. We right shift the number. So here, I think this was given int, so I was thinking they will. But if this is given, or I'm not sure of the if I mean this is given int, so we can assume, right, that this is like 32-bit or whatever is the word size on the machine.
Right. Yeah, but anyone, the interviewer might actually change the requirement right on the fly. Say what if, like Rajendra said, if it's a big number, how do you handle that? So yeah.
Okay, guys, that's all I had. I'll stop sharing now. Thank you so
And if
much.
you use the third method, the code will be more shorter, like third one, last. Which
This
you
one?
and Rajan, no, top one. Yeah, this one. Only 2 lines we'll have to write. No, the one you were discussing, n and n minus 1.
N minus, okay, yeah.
100
This
not
one.
1 not 2. Yeah.
Actually, someone
In 2
shared
lines
that.
only it is. It's like,
Someone shared that a few weeks back, where he was talking about one of the string permutation problem. He nicely used that one. That's what I remembered.
Mm-hmm.
Remember?
Basically, this is the code, right? It should not be more. Is there anything else? This
no,
is
no,
it,
it's
right?
fine.
Yeah, that's all.
Yeah.
Yeah, this is it.
And if you use
Okay,
ternary,
guys.
I think it's much more shorter. Yeah. Okay.
Correct. Okay, guys, I'll stop sharing. Thank you.
Thank you. Yeah.
Yeah, so it's what Jagrut and Rajendra were explaining, same thing. I'm just checking if it is giving you 1. I mean, both has to be this should be about like this end and and this has to go to the like it is 1 I think okay, let me unshare it. So am I audible right now?
Yeah. You are now you are clear. Yeah.
So what I was saying, like if this comes out to be 0, that means it's a power of 2. I mean, you can put it into power of 2, and not of 0 will be what, 1, and this will be true. So both are true, then it will return true. And if it comes out to be 1, then not of 1 is false, and if one of them is false, it will return false. And if this is 1, that clearly shows that you can't make it a power of 2, that number. So it works on that logic.
Mm-hmm.
So in doubt or any other approach, shall we switch to next?
Yeah, I think that's all right for this one. Jagrut covered everything in your last case. Yeah.
Yeah.
That's
what I said.
If anyone has something, yeah, they can share.
Other.
Yeah, I just joined. So we are checking n is greater than 0. So I mean, we do not check for negatives here. If it's negative.
Yeah, unsigned int we are not checking.
Okay. Is that or
they didn't say anything about that. There is no constraints in the problem. Question, yeah. So, but yeah,
no, but if it is negative, it will not be a power of 2, right?
Right, yeah.
Okay, I mean, okay.
Then you make it first, take the mod of that number, make it positive.
Yeah, okay.
And like that.
Yeah, thank you.
So next is like cath symbol in a grammar. on the first row, we write a 0. Now in every subsequent row, we look at the previous row and replace each occurrence of 0 with 0, 1 and each occurrence of 1 with 1, 0. Given row n and index k, you need to return the kth index symbol in row n. So it's like what the given n row and k index. So one row they are given and index is 1. You need to return the kth index symbol in row n. The values of k are 1 indexed. On the first row, we write a 0. Now in every subsequent row, we look at the previous row.
So he's
So if
saying
you,
that whenever you have a 0, you
yeah,
come across a 0, you need to write 0, 1. Yeah, just replace that 0 with 1, 0, 1. So it means that you need to just append that 0 with 1. But if you come across 1, then you need to append that 1 with 0.
but how we'll know that whether it will be 0 in that or 1? Like
So
one,
okay, that's the inputs are different. But first, if you look at the problem statement, it just says whenever you come to 0, you say 0, 1, or if you come across 1, you make 1, 0. But now when you go
yeah,
to the examples, it says like if you have input as n equals 1, right, and k equals 1, so it means
okay.
that you are on the first row. Okay, on the first row, you will just have only single element which will be 0. You start with 0, right?
It can be 1
So
also, right?
no, it wants to, they want to start with 0 from row 1. Okay,
Oh, one first
so
row, we write
because
a 0.
if you scroll down the example, it says, right, if you
Mm,
scroll down very bottom, yeah, so you see the row 1 is 0, and then from
yeah.
there you start constructing the other like the way it is explained on the top.
So 0 got converted to 0, 1, right?
Yeah, because you
This
have
time again
0.
they saw 0. So 0 got converted to 0, 1 and they saw 1. 1 got converted to 1, 0. So again this 0 will go to 0, 1. Then 1 will go to 1, 0. Again 1 to 1, 0 and 0 to 0, 1. Okay. Yeah.
And then you keep on repeating, right, like row
Repeating.
5, row 6.
So I have not done this, but I just read this. So I have one approach in mind. It's kind of like simulation, but if we have time, I can quickly share it.
Sure, sure. But before that, let's go through all the requirements if there is something hidden in it, and if someone actually catches it, because if you look at the note, it just says integer, right? N will be an integer from 1 to 30. So it means like you will have rows of like 30 maximum, right? Something like
N
that.
will be
And every time you increment the row, it is 2 to the power of that number, right? So if it is 2, n is going to be 30, so it will be 2 raised to 30. So it
29.
will 2 raised to, yeah, 29. So maximum it will be something like almost
2 raised to power
about
10
to
is another
overflow.
2, 4.
Yeah,
Yeah.
almost about to be overflowing, right?
Yeah.
Yeah. No, that's very good. I did not see the ranges.
Yeah.
So maybe the simplistic approach will time out.
Yeah, but this problem is slightly, I don't know, but it's very different. Yeah. Yeah, you can go ahead with your approach, no problem.
So you want to share, John? Good.
Yeah, and I'll just take two. I'll be very short because if I'm on the wrong track, I don't want to waste everybody's time. But I mean, maybe this isn't. Where is it? Share. Yeah. Okay. So basically, like if they give if n equal to 1, k equal to 1, right? So this is first row, and they are one index, so this is 0. So I just return this 0. So that's basically that's simple, right? Now then a second example was n equal to 2 and k equal to 1. So basically we have 0. That's in the first iteration, n equal to 1. So he is 0. And then n equal to 2. We know what will be the size of n. Well, yeah, what will be the size of n equal to 2? It will be double. So it will, we need to allocate 2 places for it. And then 0 will become 0, 1. So, and then now we are at n equal to 2. We look at k equal to 1 from one index. So return 0. Same thing, n equal to 2 and k equal to 2. Or we can take little bit. Yeah, okay, let's take this. K equal to 2. So n equal to 1 when we take, then same 0. Then n equal to 2, we know how much we have to allocate. So we know that we need to allocate. Actually, it's
0, 1. Yeah.
Was it n equal to 3 probably? I forgot what the question. But yeah, let's say they asked k equal to 2, then we return 0. And then the return 1 because he is in the second position, the one index. And then this guy, this one was just gives the full idea. So n equal to 1, we start with 0. And then n equal to 2, we know how much space it will take. He will take double. So he will take double. And then I browse through this guy. So wherever is 0, I'll basically maintain 2 pointers, right? One is I will calculate the size in the next. So one loop I will make for n. I want to go through n. And then in each iteration, I will look at what is the previous size that I have, and I will allocate a array or buffer of double the size. So buffer size 2, and we fill it. So 0 will become 0, 1. Then n equal to 3 we take. So we will allocate a buffer size of 4, and 0 will become 0, 1. And then 1, 0 will become 1 will become 1, 0. Now n equal to 4, we allocate buffer size of 8. So 0 will be 0, 1, 1, 0, 1, 0, 0, 1. So just this is for the first 0. This is for the 1, 1, and then 0, 0. And then last one. So we basically now we need buffer size of 16. And then we just run through the top one. So for each top one, we will have 2 increments here, right? So 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0. And then if we look at, they are saying whatever k we want from here. I'm not sure what was the parameter in the question, but if whatever k they basically this is how the iteration should go, right? And then once we have n equal to, maybe this was n equal to 5, k equal to 5. So if we look at, okay, this is 1, 2, 3, 4, and 5. So that's my n equal to 5, k equal to 1. So basically just like this one loop over. So I'll just write some pseudocode. So for I in 0 to or 1 to n, and then we can keep a counter for like previous. Maybe we start with n equal to 0, and well, n equal to. Okay, I don't want to code it live, but basically for level, let's say level equal or n equal to, well, yeah, let's say level equal to level equal to 1. Yeah, and then we will say that my I can maintain like a, I don't need a 2D array, right? I just can allocate each time. So level 1 is, so let's say array I keep of size 0 is 0. Now array of 0 is 0. Okay, now I can start a loop. So for 1 or 2, 2 to n, right? And then I can say that now my array here will be, I want to allocate a array of my, whatever was my array size maybe I keep like a previous.
Or you can allocate an array of complete n, 2 raised to n, maybe, because, and then you can keep on adding that, right? So,
So
Raised to,
Jagrut, here you are trying to, I mean, populate the all the arrays, right? All the rows.
yeah, but not keeping all of them, just the last one.
overwriting it, yeah, okay.
Yeah, so it looks, I mean, looks like a brute force, right?
And that's why I said this is probably not going to work, but just conceptually, this is what previous dot size into 2, or as I think Santosh was saying, we can keep actually one that is 2 raised to n only.
Yeah.
So yeah, maybe that's a better approach. We just say my array equal to I will have 2 raised to, or math dot power 2 up
N,
to n minus 1.
Yeah, n minus 1, sorry, yeah.
Right. No, that's right. So now, and then we just populate array of 0 as 1. And then we can go from I equal to this. So now we, whichever iteration, so we will have 2 loops. So let's say I start with 0 and j equal to false. Well, one of the issues maybe in this approach is I don't know if I might actually, so I am reusing, right? So that's why it might be an issue if we use the same array, because
okay.
now when I am generating for this, I will have to override that guy.
Oh, yeah. Okay, that is the reason you are trying to use a different array always. Okay, makes sense. So you use that as a reference, the previous array as a reference, and then you create a new array. We're looking at the elements in the first array and then populate the second one. Yeah, I got it.
Yeah.
So at least you will need 2 arrays, or maybe all a 2D array also. Yeah.
Previous equal to 1, and then we can say, we can here look at if let's say our first condition will be okay, so we are going up to n. So let's say we populate this, right, and then we will just say for I 0 to k minus 1, right, and then or sorry, I don't even need this, right? It's like my current equal to, so we can keep another array. Well, where will I define this? Okay, let's say current equal to, or we return just current k plus 1. So k is 0, no, k minus 1. Basically, if I want 1, then I want to return the 0th index, right? So let's say that is the end I return, and then we can say we will allocate like current equal to array. We will allocate previous dot size into 2, and then we can say for j 0 to previous dot size minus 1. We can say so let's say we just say what was previous element is, and I'm just making it a little explicit. So previous j so if my previous e equal to 0, and I think these all have to be they won't be ints, I think, or dim of ints. Yeah. If this is equal to 0, then what we'll do is we will basically say I will also have a counter, right, for this guy. So current pointer is 0. So current pointer equal to 0 and current pointer plus, so current pointer plus equal to 1, and then current pointer equal to 1. And we can make this more efficient, but and then else, basically we are saying that my current pointer, sorry, this is cur of current pointer, cur of current pointer. No, sorry, not this. So basically this is 1 and this is 0, and same thing we keep here. We just say 0 and 1, and then we can basically increment that guy. So basically now I looked at the previous element, and then if it was 0, I filled in the 0 and 1 in this in the current one that I'm populating, and same here. If it is 1, then I'll populate 1 0, and then what we do is now that we are here, we can then increment the previous e plus equal to 1. So now I'm advancing the, j will automatically increase. So j is being tracked by the previous element. And then, once this is done, so now we are done with all the arrays.
So you want to return the k, right?
Return the k minus 1.
So that will be outside, yeah. Completely outside of all the 4 loops, yeah.
Yes. So looks like, I mean, if I'm not wrong, so I mean there is some pattern here in that when you actually come up with 0 1.
Yeah, maybe.
Yeah,
But I think this might be the normal way of doing it, right? Only what we can do is we can save on the array space. We can use just 2 arrays instead of using a 2D array. But this will be an okay way of doing it.
Still we can't get an array size of 2 power 30.
So can I share my screen to discuss that pattern? What I think that, I mean, that is the pattern here.
Okay, no problem.
Yeah.
So do you guys see my screen?
Yeah.
Yeah.
Okay. So we know that for r is equal to 0, so value is 0, right? And when r is equal to 1, so it will become 0 1, right?
Oh, R stands for row. Okay.
Yes, and then r is equal to 2, it will become 0 1 1 0, right? And then r is equal to 3, it will become 0 1 1 0 1 0 0 1, right? So now the pattern here is that, see, this is the mirror. So what's happening, the pattern here is that whatever the value of the previous row, so reverse the bit in that and append with the value. So like for example, this guy, take this guy. So the value was, the previous row value was 0 1, right? So reverse the bit will become 1 0, right? And now combine these two. So that will become your next value, next row value. see the here. Now this is my row 2. So now reverse the bit 1001, right? And append these two together 01101001. Right? Now let's say follow this pattern and see whether we can get the next value, row 4. So here it will be 1001 0110, right? So if we combine this, so next value should be 0110 1001 100110, right?
Okay.
Let's see whether this value, so 0 0 1 1 0 1 0 0 1 1 0 0 1 0 1 1 0. So 0 1 1 0 1 0 0 1 1 0 0 1 0 1 1 0. You guys follow me?
Yeah. So in this case, what you did is you took for the R equals 4, you actually took everything from R equals 3, moved it to the other side, that is the left side, and then you flip that for the right side, right?
Yeah, flip the previous row value and combine together.
Yeah. Okay. So you are trying to say that this can be done in a recursive way, something like that, right?
Yeah.
You can use this. That's good.
So this is very nice, but then are we going to do this at the bit level, or are we still maintaining like the array?
Well, you
It
can
will be
use
a
anything.
it will be
I think in fact, if you use an integer array, it will be much easier because we just have to look for an index for the k, right?
No, it will be at the bit level.
You can do it at bit level also, but
So
why not use an array? Just use an array and then get the input. Because
so
bit
you
you
see
will
that,
need a lot of hand patience.
I'm considering the constraint that n is given that 1 to 30, right? So which means that that will be in the integer range.
Okay.
So when I say that, okay, my a is equal to 0, then what I'll do, next row will become, to get the value for this one, it will be a or till, tilde. Yeah, that will reverse my bit, right? So that will become my new a, right?
Okay.
So I will, even though we don't need the recursion here, right? We can just do that in a loop. So like I is equal to 0.
Yeah, that is also possible. Yeah.
I less than whatever the value is n, right? And then do it recursively is equal to a tilde a, right? So this will give me the final output, right? This one. And now in that output, I can use the mask and get the exact what is the bit value at that position.
Yeah.
Actually, that will be a good problem in itself. Like given a set of bits, reverse each one.
Yeah.
That helper function will be required, I think, right?
Yeah.
PS.
Helper for what?
For so when we get the left side of this, we need to flip the bits for each position. So we will need some kind of function to do that, right?
I think, I mean,
Or how will basically that mirror? So if we just take one example, the last
so
one in the
no, not
pyramid.
actually. Yeah, there is a problem here. So we need to actually shift that. So we need to actually, sorry, my bad. So we need to actually shift these bits first to the left side. So like if
that's
it's,
true.
yeah, if it's 4, then we have to shift 4 and then do the OR.
I think what Praveen, I think you were coming up with the earlier one was right. You use a mask, for every row you'll have a mask,
Yeah.
right? Based on 2 raised to that. And then whatever bits flipping you do, you can always use a mask to count how many bits you have earlier. And that will also be good for indexing when you want to find the K value.
True. Yeah.
But still, can we allocate these kind of size?
No, just the integer.
No,
No,
at n if n is equal to 30 and level 30 will have an array size of 2 power 30, right?
No,
No, so
actually,
2
it will
2
just
to the
be
power 30 is, so the value will be in the integer range, right?
yeah.
So just one integer should be enough.
Should be enough, yeah. Only thing is bit thing, as Jagrut was saying, an helper function would be slightly challenging, but yeah, it
I'm
should be
talking about
possible.
the array size, array in which you store zeros and ones.
He's not even using an array. He's just using a single variable, integer variable. Right, Praveen?
Yeah.
And zeros and ones are stored in a string.
No, he's
these
just
are
using
just the bits.
Okay.
Yeah, these are just the bits.
I think it's a
even
very
then,
highly optimized version.
no, even then,
Uh-huh.
your range is k, right? Which is 2 power n minus 1. Like if it's 2 power to 29, like for example, k is 3, k 7. So it will go up to k 2 million, your index.
K is 2 raised
2
to
raised
n
to
minus 1, right? So n is 1 to 30
Yeah,
only.
to 30, yeah. So 2 power 29 is like, it will go up to
Yeah.
200,000.
Yeah.
your 10 raised to power 6.
200,000. Yeah.
Oh, yeah.
What did he say?
Okay, see, if the K is in the range of 1 to 2 raised to n minus 1, right?
Yeah.
So n is 30.
Yeah, n is 30.
Yeah, so 2 raised to n 29 minus 1
It's
is
2 million.
2 raised to
It will be 10
29.
raised to power 6 something. Yeah.
It
Yeah,
won't
it
fit in
is like,
32 bit, yeah.
yeah, 2 million. So you can't shift up to 2 million.
Oh, yeah, right.
That can create an issue.
Yeah, we might have to use an array first, maybe just do with an array. Okay, get that, and then we can actually combine them in 32 bits and then find something.
I don't know the solution, but I think even the array is not the solution. But I think we should be able to do with the divide and conquer. Like for example, if it is if the row, right? So maybe it is a pattern. You don't have to do up to 30, or you don't have to do, yeah, up to 30. Like you divide 30 by maybe to 15. You just have to do up to 15. And then if it is 30, just do 15. Maybe you might have to reverse the bits and then get the index.
Mm-hmm.
That way it is faster, and also it won't run out of space or run out of time, as you don't need to calculate up to 30. If you try to calculate 30, it won't be sufficient in the machine.
We can do it in one space.
Okay.
Then looks like I misunderstood something here, right?
No, this was actually good actually for an
Pattern
understanding the
matching,
problem
this is
statement.
good.
Yeah,
Yeah.
absolutely. This is required, because other than that, you won't be able to visualize how the problem is and the gravity of the problem. This is very, very required. But only thing is, if we can't fit in 32 bit, that is my bad actually. That is not correct. Yeah, but then we'll have to use either an array of all ones and zeros will be separate array. But as Pradeep said, it won't be feasible also, right? So maybe use a divide or conquer, or maybe what Dilip has have something.
I solved it in O of on time and O of on space. Uh, can I share that?
Yeah, sure. Let me stop.
But Dilip, that will be the most optimized version. Why don't we actually understand what Pradeep is saying first? Yeah.
Okay. Yeah, sure.
So that will be something maybe in a slightly intermediate state. So then we can go to your solution.
Yeah, something, I mean, we can think easily,
Right. Yeah.
or with little bit
at least,
help at least.
Yeah, at least you give some pointers, or else it was very difficult to come up with this solution also.
Yeah,
like
otherwise
this,
the first solution what Jagrut actually immediately that will come in everyone's mind.
Yeah, that I thought that is the only thing.
this
Actually, we can.
mirror identification is very nice. Like,
Absolutely, yeah.
yeah.
Even my intuition starts from looking this whole pattern as a tree structure. Like practically, you will not have real tree, but you can assume it's a tree and see how we can go there to that level and solve.
Okay.
I think please share.
Yeah, Pradeep, please share.
Let me
No, not me, Dilip.
Should I give a clue or explain my whole approach?
No, you explain your approach, because that will be slightly easier for us to follow.
Yeah. Let me assume this. Right now I have 4 levels. Let's assume this whole thing as a tree. So first 0 in first row is my root value. Okay. So this is what I have right now. I don't have the whole tree in real memory. So if I want to go left, I know from 0 we generate 0 and 1. So if I go left, I'll get a 0. If I go right, I'll get a 1. And if at some point, if I'm at 1, if I want to go left, I know if I go to left, I will get a 1. And if I go to right, I will get a 0. Right? So what we want to do is, right now here, we want to reach level 4 and 5th element in that level. So we need to reach this level, and we need to find what's the value in this index, like this value. So somehow we need to traverse the tree, like to reach this node. What we need to do? First, we need to go to right of the root. Then we need to go left of the root. Then left of the root, right?
No. Okay. So first, how did you say, like on the row 2? I slightly missed
draw
that.
it in a white.
Please, yeah.
You can see the whiteboard, right?
Right, yeah, we can see it now.
Yeah. See, for suppose this is my root. I need to travel level 4 and 15 index value.
Okay.
First, let's assume how we can go to that level. It's just a tree. I have a root value is 0. Then I need to go to next level. If I go to left of my root, I know it's 0. Okay. If I go to right, then it's 1. And for this, let me draw the tree and
Okay. So you are saying that based on what your root value is, that is the way you will decide your left and right child's value.
Yeah.
Yeah, that is actually coming up, no problem.
Okay. So if I need to go to level 4 and this value, this is the fifth value, I just need to traverse only this path. So that way I could, when I reach here, I'll know the value is 1 and I can return that.
Okay, but at every
How will you
level,
decide
how
the
are you
level?
going to take the decision?
Yeah,
I'm
so
going to
so
left or right.
that's where the like decision. So it's like for when I'm at level this level 4, I should know whether I need to go to left or right. So if I go left from this level, I can access this part of the tree, first half of that level somehow, right? If I go take right, then I can have access of the other part of the elements in that level. Okay, so first I need to see I need to visit element 5. I know at level 4 I will have 2 power 3 element 2 power 3, which is 8 elements. Okay, so I know it's 8. So 5 would be greater than 8 by 2, which is greater than 4. So I need to go right side in this level. Okay. So I went to right. Now my number of levels are 3. Okay. Now I need to consider only this part of the tree. Okay. So now I have 3 levels, and I will update my value 5 with. Okay. So I'm going right. I will not update the value now. So now. Okay, wait. I need to update my value. When I'm going right only, I need to update the value, which is 5 minus 4. It is 1. So at level 3, I need to visit first element in this level, in this part of the tree, in this level, in this part. So I need to go. Again, it is less than half of that level, so we need to go left, and like that I will find this value.
I think actually here, you know that this is a perfect binary tree, right?
Yeah.
Symmetry.
So then based on that, we had to decide that we don't need, whether we have to go on the left or right for this particular node.
Yeah, that's right.
Okay.
So how you are deciding whether left or right?
Yeah, so when you are at the root and you know that your tree is a perfect binary tree, so you know that how many number of nodes are on your left hand side and how many number of nodes are on the right hand side.
Yeah.
So at root,
But
if you know that, okay, you have 4 node on the left hand side and 4 on the right hand side, so your 5th node will be definitely on the right hand side.
Yeah.
Oh yeah.
But
That's
no, that makes sense. But then when we go to the right side, do we change that value 5?
Yeah.
Okay, that we are looking. I missed that part. How we are updating that?
Because we are considering only this subtree. I will be starting from this level on. I won't consider these elements in that level. So I need to start half of it. So that's why I'm subtracting half of the elements, so that my indexing starts from this part, the second half of that level elements.
Got it. Very nice.
And how do you keep track that whether the value is 1 or 0?
If I'm at level 0, left, then it's 0. If I'm going right, then it's 1. From a 1, I'm going left, it's a 1. I'm going right.
Oh, so you are considering that what is my current value, and based on that, okay, got it.
Yeah, if I'm going left, it will be same. If it can be anything.
Okay.
One, it will be
You are pushing from the parent node that what is the value of that road? Okay.
Yeah, that's right.
Very nice solution. Very nice.
This is pretty cool. It's kind of tracking 2 or 3 things actually.
Yeah.
That's really good problem.
Yeah, but there are a lot of ways, a lot of things to keep in mind, right? One is decreasing the value of that k at every level, and second, looking at the parent value and taking a decision of also what the next value will be in the right and left. Yeah. Good, good. Yeah.
So it will be log n only, right? Worst case.
No, n O of n. Like n is the number of levels, then n.
Oh,
Actually,
No,
recent,
why n?
He's taking the number of levels there. Yeah, I think, yeah.
but it is a balanced tree, no?
It's a perfectly balanced tree, right?
Yeah.
But you
So
need to
height.
traverse. Yes, sir.
Why
Yeah, go.
why
So
do you
height
need
will
to
be
traverse
log
the
n.
other side?
No, n doesn't mean number of elements in the tree. N means the number of levels.
Okay,
Yeah.
okay, yeah. So number of levels.
it's basically log n,
Yeah, it
where
will
n
be.
is number of nodes.
Yeah,
Nodes.
number of nodes in that. So
Right,
log
right.
n.
Yeah.
Yeah. That is because it is a
Problem
balance. Hmm.
in problem, it's n is the number of levels. So yeah.
Yeah, but we can always tell the interviewer it is much efficient. So it is the number of nodes we are actually interested in, because K is that, right?
We need
Yeah,
to.
the K is huge.
Yeah.
Yeah.
Actually, while we are discussing this, recently there was some problem on read code, which can use the same approach. It's like given a not a complete, not a perfect. This is called a perfect binary tree, right?
Complete, no? Or this is perfect? I think
This is
Perfect
complete.
binary tree.
perfect, and the complete one is where nodes can be missing, but they will only be missing from the very right. So the leaf, all the levels except the leaf are fully populated. On the leaf, all the levels, all the nodes are populated going from left to right.
Left to right. Yeah.
So that is a complete binary tree. And in that, the question is like, get me the validate whether it is perfect or whether it is complete or
Complete.
not.
Mhm.
So in that also same kind of approach can be used. The same
What was the
way.
question?
So it's saying
But
that given a complete binary tree, validate if the tree is a complete binary tree.
Binary, yeah.
So, and the property is that all the nodes are except leaf are fully populated, and leaf is populated from left going to right.
Yeah.
So complete binary tree is heap only, right? You have to verify whether that is a heap or not.
No.
I think Jagdutt, are you talking about that problem where it was said that it's a complete tree and find the total number of node in that?
No. 1 minute. Let me.
Complete
Okay.
binary tree.
No problem. We will discuss that after our session.
Yeah.
Okay.
Yeah.
So
Let's
can we
move to
just
the
go
next.
ahead with this solution? Yeah.
Should I
Dilip?
share?
Yeah,
Yeah.
please.
Yeah. So the number is 958.
958. Okay.
So something like this can be used. Is this recording available afterwards?
Yeah. It's
Yeah,
available.
you on YouTube.
Okay.
So you can subscribe to SD Skills channel on YouTube, and they have a weekly or or all the previous recording you can find.
Okay. Thank you.
Yeah.
Yeah. So first my symbol is the root value, which is 0. Then I'm taking count, like a number of elements in the nth level. So that would n minus 1 shifted right. So that will be 2 power n minus 1. Then I'm taking for loop and iterating to that level until that level. Inside that level, if suppose k is greater than count by 2, that means I should go to right side of the root. If I'm going to right side, I need to update my k value according to that subtree and change the symbol from 1 to 0 or 0 to 1. If it is on left side, I don't need to update my k value, and also I don't need to update my symbol. So I will just change the count of the nth level according to that root value, and so on. I move like that. When I come out of the loop, my symbol will have the value at that index, that level value.
Okay, so you are using a for loop. Okay. You don't even construct any binary tree. Okay, just
No, I told you,
yeah.
we assume we have a tree and we go on with that because
Yeah.
we know what will be on left and what will on right.
Yeah, makes sense.
Same
I
is
think
like heap, like we make array, but we consider imaginary that there is a tree.
yeah, it is like a heap
Yeah.
heap array property, correct.
Exactly.
Yeah. So can we not use that heap array property, but yeah, it will have an extra space.
Space it will take here. That's
Yeah.
the
Yeah, but again, we'll have to come up with the 0 1s and 1 0, the way pattern he was describing, Praveen was describing, right? So
yeah.
at one level, you have to come up with, but this will be a more efficient way of actually getting that. But that will also be a good way of doing that.
But we don't need sorting and all something concept as such. So that will be add-on, I think, overhead kind of, right? We are not using any sorting property here. A normal tree heap and all we use like if we have some, if we want to use some property of sorting or something like that, getting minimum max.
No, I was thinking like if you just have an array and construct a heap based on that. Yeah, but I think
Nodes.
no, that will be different thing. Yeah, no problem.
Yeah.
So yeah.
So in this, Dilip, if we are going right, only then you are actually doing the work, right? So if
Yeah.
k is greater, then that means that I'm going right. And then if I'm going right, I will reduce my k by the number of leaf nodes that by the number of half. I'm basically discarding half of the tree on the left side.
Yeah. And after that, I'm taking that at u. Like
What is
in 8, if your value is 5, in the next subtree, your value will be 1 because you are discarding the first 4 and the new index of the k will be 1.
But you don't have to look for if the symbol equals 0 or 1 for the left side.
Because it will be same. For 0, it's 0, 1, and for 1, it's 1, 0. So if you go left, it will be same. See here, if 0, if you go left, then it will be 0 only.
Oh, okay.
For 1, if you go left, it will be 1 only. Only if you're going to right side, we need to invert that.
Okay.
Yeah, is flipping the symbol actually.
And it is useful because we are using binary. I mean, 1 0 and 0 1 value we have. If we had other values, I don't think so. Like
yeah, then the problem would be slightly different. Yeah.
Different. Yeah.
Traversing would be same, I think so, but handling the symbol would be different.
In the for loop, it seems like we go from the bottom up, right? The last level to the top level. And how do we know the symbol at the last level is begin at 0? I thought that we go from the first level, the root go down to k, but then if we go from level k go to the top, then
Dilip, if we have time, maybe it can take 2 minutes and quickly do like a 4 level, like a 2 or 3 level tree and just see how it actually runs.
Yeah, you just walk through with a problem. Yeah, test case. But yeah, what Leon question is, are we not doing it from row 1 to row 4, right? We are going from top to bottom, right?
Yeah, we are going from top to bottom, row 1 to row 4. Like we are starting. This is a root. This example is exactly like that. You can assume this as a tree. Here, I'm traversing to the level and the index I want.
Yeah, I was also assuming that. But Leon, are you talking about bottoms up or DP approach?
No, I thought like it go from level row 4 to row 1.
No. He's doing it from top to bottom.
Yeah,
Row 1 to
from
row
top
4.
to bottom, because I know it first value is 0. If I go from level, I don't know which index it will be the value of that.
That won't be possible also. Yeah. Okay.
Like,
So
if you
what is
want,
the advantage of going from bottom to top?
No. We were just brainstorming whether it is possible or
Okay.
not. Yeah.
Oh.
It is not possible because we have the value of row 1 as 0. Because for the
Yeah,
low, we don't know anything at the rows, right? So we have to start from the row 0. Yeah. Row 1 or
top
0.
to bottom.
Yeah.
Makes sense.
Yeah. Good.
then if you want, I can explain again if you didn't get
Yeah,
it.
that's fine. But can we just walk through with one of the example what
Yeah.
Jagrut was saying? Take a test case and just walk through the code, so it will be more easier for everyone to.
Now should I go it now or later?
We can just do it here. You can just
Yeah.
copy one
Okay.
of the test case
Yeah.
and then.
I will go through this example
Right.
and 4
Yeah.
and
Yeah.
5.
Right.
So let's see. My symbol is 0 and level count would be 8, right? Like 4 minus 1 to 2 power 4 minus 1 is 8. So this one.
Okay.
So I'm starting this way. So my for loop is going to iterate n minus 1 times. So from 1 I'm going to iterate. So until 3 I'm going to iterate that. So actually I'm already at level 1, so I'm only iterating 2 times. So until n minus 2. Okay. So right now I have this value. So now I need to decide whether I need to go to left or right based on number of counts and my k value. And k equals to 5. Okay. So this way. So now I will check the condition whether 5 goes into the left side of left subtree or right subtree. So that I will check with 8 by 2 is greater than 5 or not, and it's false. So I need to go to right side, right? So now so this condition goes true. I go inside and I update my k value as k equal to k minus n level. So k is 5 minus 8 by 2 is 4, and my updated k value would be 1. My symbol would be right now my symbol is 0, so my symbol would be 1. Okay.
Yeah.
So that in loop one I got my symbol 1. Then I'm going to symbol 2, which is right now I'm at row 0, row 2. So now I will check whether sorry, this one goes to 4 and count. Now I will check whether 4 by 2, which is 2, is greater than 1 or not, which is false. So I don't do anything. That means I'm left. So my symbol stays 1, and my n level count becomes 2. Okay. So again, I'm at level 2, and my symbol is still 1. Okay, I'm going to next level 2. So now my n level count is 2, my symbol is 1, and k value still is 1. So now if my n level count by 2, which is 1, is greater than 1, is false. So I keep that as I'm going to the left, so I'm not going to update my symbol. So my value will be 1. So I come after the loop and return symbol.
Yeah. So here the trick is your n level count. You actually use the value for the row 4, right? It's the reverse way you are using.
Sorry, can you repeat that?
So your n levels count initially you have initialized it to 2⁴, correct?
Yeah.
Yeah.
2
So 2⁴ minus 3 or something like that, right?
Yeah.
Yeah. So that if you don't get that, then this won't work, right? So you need to understand because you'll always think, okay, I'm on row 1. Why I should have a 2⁵ minus 1, correct?
Yeah.
So
Yeah.
that doesn't come very easily.
Even I was, when trying this intuition, I was stuck with that part. Whether I need to go left or not, how much in vertical, horizontal I need to move on the tree. So this gave me the way, like whether number of I need to go to the left part of the tree, right part of the tree. That with the count, I got that intuition.
Okay, that's good.
Yeah.
Man, this is super. There's a lot of subtleties in this code, actually.
Yeah.
I was solving this problem until we are discussing first problem. At the end, I got this.
Oh, really? You just
Very
did it now?
Just a few seconds before we start the second problem, I got this accepted and I solved it.
Oh, cool. I think, yeah, you please share this code on our chat,
Yeah.
so we can work it our way. Yeah. Good. Very nice. Yeah.
It's a very optimized one.
Yeah.
And, then we can switch to next, or
Actually, I think Dilip's code is very good, and maybe we can write it in a more, when we are first writing it, we can write it a little bit more explicitly. So with the variables and all that, so it's easier for us to recall. But that idea can be borrowed and sort of written it in a nice way, so that otherwise looking at this code, maybe if I look at it after 2 months, I'll forget what's happening.
Yeah. But at least now the idea he explained is really good. Or maybe we came up with all the brainstorming sessions, how we started with Praveen's solution and then came up to this. Or you also started, right, Jacob? So yeah, and now things are slightly much better than what I started earlier yesterday.
Yeah, I mean, I think it's at least at the ground level, we need to understand what the pattern is, how it is evolving, and then how the optimized is getting there. Otherwise, I think it's difficult to just appreciate how we get there. Otherwise, we'll just probably be memorizing, oh, go left, go right. And if some parameter changes, then we are stuck.
Yeah.
We are screwed. We cannot move forward.
Yeah.
Stuck in left hand.
Cool. Yeah. Let's move on. Yeah, sure. Yeah.
Third one. So a linked list is given and we need to reorder it. So like 1, 2, 3, 4, and the reordered list is like you may not modify the list nodes, only nodes itself may change. So they have reordered like 1 connected with 4 and 2 and 3 like this. Yeah, so yeah. So the it's like first node, last node, first node, then last node, again second node, second last node, third last node. Like L0, then L0, last one, then L1, then second last, then L2, third last, L3, then third last, fourth last, yeah, like that.
So we are given a singly linked list, right?
Yeah.
And nothing other than that. And they're asking us to not modify the values, but we can use extra space. There is nothing mentioned.
In an alternating fashion. Yeah, extra space they haven't mentioned.
Yeah.
But if we don't use that, I mean, if we use it, I think that will make problem little bit, what do you say, more easier, right?
Yeah. So, you just, that will be like use a stack and just push the whole string.
Yeah, exactly.
Okay, inside it. And then when you're pushing in the stack, you can come to know what is the length of that string. So when you're
Okay.
popping from the stack, you can just pop out only the last half of the string, half of that list. And when you're popping it one by one, you can use your first linked list and just intermingle the reorder. Something like that, yeah.
Yeah, exactly.
But with a stack.
Is there an example of like a odd number of elements?
Yeah, there is, like the example 2 says, right?
Okay.
So 1 with 5 and then 2 with 4 and 3 will be as it is because we don't have any pair for 3.
Yeah, so we cannot modify the node's values, but can we like add extra pointers in the node? Something like, can we convert this single linked list into doubly linked list?
I don't think so. We can modify the node structure, but we can add some more pointers.
Doubly linked list will make it reversible, right? From last to first, first to last.
Yeah. But
More
they have not
flexibility
mentioned
to
anything like that. Yeah.
But then, yeah. So how you'll have to use extra space only for making doubly linked list, right? Or here only you can make.
No, I think Upendra, right? Upendra was asking, is that more possible? Can we modify the node structure? That is what he was.
They haven't explicitly mentioned.
No, they have
it.
not said. Yeah, I don't think so.
Yeah,
I
you
mean, it's
may.
written there that only node itself may be changed. So I didn't get it. Like,
what is that?
Node like pointers you can change and like one is pointing to for those things. Like he's talking about pointers.
Oh.
Nodes like along with the value and address, that entire you can shift it, something like that.
Mm-hmm.
Yeah, not the like inside value. Inside the node you can't change the value.
okay, got it.
Otherwise that will be easy, right? If you are at this node 2 node 4 node, you just in place of 2 you put 4 and at place of 4 you place 2. So you don't need to play with the directions and pointers. That will be like normal swapping, I mean overwriting the values.
Yeah.
Yeah, that will make it very easier if they give that, if we can change the values inside nodes.
No, I was not talking about nodes value. I was talking about like adding extra
Pointers.
parameter. Yeah, extra pointer.
So for double linked list, you'll again have 3 sections in one node, right? One for the forward pointer, other for the backward pointer.
Yeah.
I'm thinking here, I mean, actually just split that in 2 and then reverse the second part and then merge.
Yeah. That's also a nice.
That will be the most
right?
efficient way of doing things.
Yeah, exactly.
Like one can be like, can we maintain 2 pointers? Like for one is at head only, and the next pointer will be at our at the last node, and then what we do is pick up the last node and change the pointer at the head, which is our first node. And before doing that, we save the this last second node and like save this and then use it again. Like this will be done in loop.
Yeah,
For
that can be
modifying the
done.
pointers, right? Yeah.
But how can you do? How can you go if you are at the tail pointer? How can you go tail -1?
Yeah, you need to
You are
have
using
tail preceding
No,
pointer.
oh yeah, we can only go to.
No, you can have. You need to have tail preceding
thinking
pointer.
of the same approach, but for that we will need a doubly linked list. So that's why it's not possible.
No, instead of doubly linked list, we can use a recursive way. You know, you can use a recursive function and do that. I think that approach might work. But if you
See,
use a recursive function,
the brute force is what Sonal mentioned. You can have 2 pointers. One is tail preceding. The tail preceding is the one which points to the previous one. Like if you have 1, 2, 3, 4, right? The tail preceding will point to 3 and tail will point to 4. And then you can, and the head will point to 1. And that way you can swap or move out the nodes and you can point 1 to 4 and then you can play with that. So the other one is what Praveen mentioned. That is the optimal one where you divide list and then reverse the second half and then merge it.
Yeah.
So how will you break the odd
maintaining-
list?
Sorry?
I mean, how will you break the odd length list? Like half you will break, or
Yeah,
like
you
6,
have to
if
break.
the
You
list,
need to find the middle. Half is you will find it at 3
and
or
here,
2. Yeah, 5. You find it at 2, and then you reverse, like you do this 3, 4, 5, right? 3, 4, 5. You reverse the list of 3, 4, 5, and then merge it with 1, 2.
So one more thing we can't do. Let's say we'll find the mid of a linked list and reverse from mid to the end, that part.
Yeah. That's the one. Yeah.
And then play with the pointers.
Yeah.
The only thing is the way we truncate the mid part, right? If we do like I was just drawing it. So if we do 5 by 2, then if we take the lower side, then it's 2. So the first 2 will be there, and the last 3, 4, and 5. Those guys have to be reversed.
Yeah.
Can you like explain once how recursive will work? Because see, I'm just taking the normal test case of 1, 2, 3, 4. If we go recursively, 1, 2 will become 2, 1, and 3, 4 will become 4, 3. And then when we merge it, we'll get 2, 1, 4, 3. But I think that's not correct, right?
No, you don't need to reverse the first one. You just need to reverse the only one list. The second part.
Second half, yeah.
Second half. So 1, 2,
And then
4,
we
3.
need to-
So you will have two lists, 1, 2, 4, 3, and then merge these two.
You reverse this 3, 4. Instead of 1, 2, you reverse 3, 4.
Yeah, and then 1, 4 you connect, and 2, 3.
Yeah. So this won't be reversed.
But
So you mean like intercalate them, not simply merge them. Just take the alternate elements.
Exactly.
Right?
Yeah. So this is like optimal one. The first one is brute force, which we usually think of using pointers, tail preceding tail and head. That is not the optimal one anyway.
Yeah, but sometimes getting that also will be crucial, in an interview. So
yeah. Like what you were mentioning, like using a stack, that also is.
Yeah, but that will be an extra space. You just push everything in stack and then you do it. But doing the way what Praveen said was the best thing to do.
Exactly, because no extra space and all.
Yeah.
Actually, when we see, right, I think Praveen's solution is also implicitly kind of like a stack. Because
if you consider that
I mean, it's a reversal kind of, we can use a stack for that.
Not
You
it
don't
does
have to
not
use
use
a
a
stack,
stack.
right?
You can iteratively,
you can do
reverse
it.
that.
Pointers. Yeah.
No, I'm just saying that.
Okay. Yeah.
Reversal 2 ways. We can do a stack, or we can do it just recursively with manipulating the pointers. So it is.
The other way, what I'm thinking here, that in a recursive way to sort it, resolve it. If we recursively actually we pass the head to my recursive function and reach up to the end. So when I reach up to the end, then it start modifying the list, right?
Yeah.
So
then you take the head and the last one.
Head and then append the last node into that and move forward that and return back to the parent and do the same thing at the parent.
Yeah.
Yes.
No, but here in that case, actually, we need to.
Another pointer.
No, you are right. I think we pass the mid, whatever is our mid plus 1, let's say.
Yes.
That will be the head.
Yeah, we need to find the mid anyhow, so that we have to stop the recursion up to that level.
No, you don't have to find a mid. Actually, you have to have that base case for your recursion function saying if you are both pointers on the same node, then you actually return. So that will be your finding the
Oh,
midpoint.
yes, you are right. Yes. Yeah, I was struggling to thinking, not able to think that. Yeah. So yeah, that is one way too.
So I was thinking if we, let's say we find the mid, right? In the original list, we find the mid and then we take mid plus one, which is the head. Mid or mid plus one, depending on
I
whether
think
we
they
have.
say mid plus one, yeah.
Huh.
Okay.
Then say reverse that list with that as the head. So that now that will give us the head of the reverse list. And then we just attach it to the existing list. So basically my existing list, let's say 1, 2, and then he will get the head of the reverse list, which is 5. So then that list will basically be 1, 2, 5, 4, 3. And then we can do our piece by piece merge one at a time.
Yeah.
So for this merging, you will take another list, right?
No, I think
These
it can
are
be
just
done.
the
Okay.
node. So you have to just swap the pointer.
But like in that tail and proceeding tail, in that also we are changing pointers only. So I feel like that is also in place and this is also in place. So would
Yeah,
the
both are in
complexity
place. No, both are in place,
will
but
be different.
yeah, both are in place, but the tail preceding one you have to traverse every time. If the list is big, you have to traverse every time to end of the tail, and you have to keep tail proceeding. Here you just traversing up to the midpoint, and
So
you're just reversing one
basically
side one time.
here it is n by 2 and that is full n, like, and where n
Yeah,
is the
that is
number
it.
of nodes.
Yeah. You traverse every time. Yeah.
That is also okay, but the only problem with that approach, because we are using an implicit call stack, right? So you are using more space there in the recursion.
Which one? Which one?
In the
Oh,
recursion. Because recursion, you are using your call stack, no? That actually.
Well, you don't have to do recursion, right? To reverse the list, you can still use a pointer. You don't have to use the recursion.
If I understand that correctly, tail preceding, so that looks like any square solution, right?
Yeah, every time beginning he has to go.
Yeah.
But lot of pointer manipulation is there in the tail precedence method, right? Compared
It's
to
not.
the.
I can share. I done that.
You have
one.
that? Okay.
Yeah.
Good. Let's have a look at it.
Give me 2 seconds.
Sure.
I need to find. Sorry, just 1 second.
But Praveen, in the case what you were talking about, till Pradeep comes up with a solution. So even in the case where we actually split it and then reverse that, so the end actually position of a reverse string will be pointing to your end of the position of your forward string also, right? So that is slightly, because usually what everyone will think, you just split the string in the two parts and you make the first string point to a null position, right? But if so you're actually explicitly cutting both the string, both of the list in two different parts.
So which solution you're talking? I mean,
the one you said, like.
Oh, the recursive solution, right?
Non-recursive, the non-recursive one. You just cut it into two.
Okay, cut into two and then reverse the second one.
Yeah. So, but you are not saying explicitly to cut the list into two. You are just saying that find the mid position and then you reverse it, right?
Okay.
Yeah. So
I
that
meant that, I mean, split the list into two and reverse the second part and then combine these two based on the requirement.
Oh, you said you explicitly to split the list into two parts? Okay. Then I didn't.
If I missed that, I mean, that was the intent.
Okay.
Maybe I missed that, but that was the intent, to split the list into two parts and reverse the second part and then combine based on the requirement.
Okay.
Yeah.
No problem. Yeah. Then that will be at least easier to do. Or else you'll have to have one more headache. Yeah. Yeah, go ahead, sir. Pradeep. Sorry. Hey, Pradeep, you are on mute.
Oh, okay. Can you see the screen? Did you see the
no,
screen?
We just saw and again you
we
went-
saw and then
Okay, can you see now?
Yeah, I can see. Yeah.
Which one are you seeing? Just the notepad or?
notepad.
Yeah.
Oh, okay, okay. So yeah, so I'm pointing to the head, keeping the head pointer as H1, just one. I'll be traversing using this head pointer. So I'll check whether these are usual checkings. And then I'll have this tail now is currently pointing to the head. Tail preceding is pointing to the tail. So there is a for loop which will traverse till the tail, but I also keep track of tail preceding. So this one will keep follow the, so it will keep track of tail preceding, and then this is just a pointer manipulation to swap the last node with the first one. So every time you have to traverse to keep track of the tail preceding, and then make sure tail preceding is not the same as head if you have just given the one node, right? So then you have to break. So those things you just need to maintain.
So what is that condition 9? Tail pointer is equal to head. Like you are checking the address of both of address are same. That is it?
This is similar to like what just Santosh mentioned in that recursive solution, that to break.
Oh,
Yeah.
when
Yeah,
both
you
pointers
can do it
match.
here or here, anywhere.
Oh.
Yeah, so that's,
Not got it.
But this code also looks very clean and very
Small.
small, concise to implement. Yeah, though it's not so easy to implement. Though.
yeah, but the time complexity is more. It's not it's n square times O of n square. Okay.
Yeah, I mean that's the best case too. I mean, with the start with that, and then if interviewer want more optimization, then look for other solution.
Yeah.
So here just I mean what Praveen was mentioning, like get the midpoint and then reverse. So this code is, I mean, I've created a slow pointer and fast pointer to just get the middle point of a linked list. So this is the code which will give you the midpoint of the linked list. So once you get the midpoint, I've made two functions. One function will be for reversing that list, and another will be the original list and the reverse list to merge them. So I'll get the midpoint with slow pointer will give us the midpoint. I'll pass it into the reverse function, reverse list, and this reverse list will just reverse your linked list, the second half of the linked list, and will return you ahead with that second. And third will be like I'm just merging the alternate. I'm merging like first one will be merged with 4, then 2 with 3. This node will give you for that. So here just I'm creating a dummy node, and as long as L1 will be pointed to the original list, the first half, and L2 will be pointed to the next reverse half, and just we keep on one from to the dummy node. L1 I'm appending, and so L1 will go to 2, and again that side the second one L2 is there. L2 I'll be appending to this dummy pointer, and then L2 I'll increase. And at last, if I'm left with L1, I'll directly append everything to my dummy pointer. And if you are left with L2, this is like one list is over, the other is remaining. So directly, rather, because you don't need to traverse the other one, so simply append directly whatever remaining is there.
Yeah, maybe
and
the
just return the dummy dot next. Yeah.
So your L2 is the reversed one, right? And L1 will be the normal.
First one, original, first half without reversing.
Okay. Yeah, but too much of implementation, right? Being Python also. So you have to do so much of, so then we need to be very careful while
It is like
implementing
small, like it is like we already know how to reverse, how to find the midpoint. That is one problem, right?
Okay.
If somebody gives, and secondly, reversing a linked list, how to reverse a linked list, that is another problem. And this is also a problem only third, like how to, I mean, in code there is a problem like how do you merge a linked list. So 3 problems they have condensed and put it into one.
Yeah, so merging two lists, sorted lists, there was a problem earlier. So that would be easier to implement using a recursive way, but you have done it this way. So the iterative is more better, right? More efficient. Yeah.
Yeah, but larger, I mean, bit more, I mean, taking large number of codes, like lines. But time complexity order of n only for reversing n. Again, for appending also order of n plus m, which is whichever list is larger. So order of m will, if m is larger, O of m will dominate.
But you are actually reversing, right? So you'll going to traverse the half of the string to reverse it. So that is one thing you are doing. So it won't be O of n, it will be slightly more, no? One you will reverse, and then when you are actually merging it again,
it will be O of n plus n, which will be n.
O of 2n something.
Yeah, I mean, some constant will be there, k into n or something like that.
Shashank, can you scroll a little bit down to your merge group?
Oh, merge you want to go. Yeah. So I've taken a dummy pointer, the first node I've appended to it, and now I'll move the dummy, L1 will move to this. And then dummy pointer will also move to, because initially dummy is connected to 1. So that pointer will move to 1. And again to that dummy ptr.next, we will append L2 and then again move L2 and just keep on doing. After that, if you find that one list is completely over the other list, something is left, you directly append it. Either it can be L1 or L2. Yeah.
Okay, so your dummy pointer is basically the one that all the values, he is accumulating the values, and L1 and L2 are iterating over the sub, I mean the two
list.
halves.
Sublist. Yeah. Yeah.
That's a good technique, using the dummy pointer. I think that is simplifying the code.
Yeah.
That is true. Yeah.
Reverse the first half also work. Is it right? If we, instead of reverse the second half, we can reverse the first half.
No, but they're telling you have to start with first list. So why you need to reverse? They're telling you to first element should be there. Had they asked us the opposite way, like ln, l0, that way I think first half reversing would have worked.
I think it may, like, when you do it piece by piece, either you append it to the tail or you prepend it to the head.
Should work, but
the reason I think of it is like you can reverse the first half at the same time that you find the middle of the list. So, if we do that way, by the time we find the middle of the list, we already reverse the first half. Then, we need to merge them only.
But that it says that, I mean, should be the head should be the L0. So when they will actually verify, so it will not pass the test case.
So in this case, let's say we reverse the first half. For example, 1, we have 2, 1, and 3, 4, right?
Yeah.
Yeah, so when we merge 2 and 3, right, for 1, and then the next time we have 3 and 4, we append it to the head of the previous result.
Yeah, doing the reverse wave, that is what is saying, the merging also.
Yeah.
So you can do it in O of n. That is what it's trying to say, correct?
Yeah. And that way we can reverse the first half and find the middle of the list at the same time.
It won't be clumsy bit, like it seems. I mean,
but then how do you find the middle? You'll still have to go through traverse to using the pass
end of the list.
Yeah.
Yeah, we still find the middle, but while we find the middle, we can reverse
Okay.
the first half,
Yeah.
right?
Yeah. But it will be slightly complex to implement during that time.
Exactly.
Yeah, that will introduce the extra complexity because when you will actually combine these two lists.
Yeah. But he's saying that if you want to be more efficient, because I said, this Shashank solution was slightly more than O of n, then he said, then this is an option, So we have some option. Yeah.
Yeah,
Okay.
if you're using, if
Yeah,
you're
that's
reversing,
good. Yeah.
if you're reversing first half, right, then you have to use a stack. You can't use pointers. So that time, if the list is big, the stack will overflow.
But then if we should reverse it only when we move ahead of those pointers,
Yeah, but this
something
is
like that.
single linked list, right?
Yeah, we reverse it like as we go,
okay.
so it shouldn't have any overhead.
Slight, yeah, there will be complexities involved. Surely, it won't be a straightforward solution.
Yeah.
Yeah, but that's nice. You brought it. Yeah, good one.
Approach.
Yeah, thanks, Leon.
In that sense, I wonder if there is like a one pass solution to do all this.
It's almost a one pass. Yeah.
Yeah. Because technically, you can maybe envision there is some solution that just 2 pointers moving through, only one person doing all this.
Yeah. So, but this is good for discussion, because when we have implemented the way Shashank implemented, and then if the interviewer asks us to be more optimized, then we can actually talk. But if he asks us to implement, then that will be a problematic one too.
Yeah,
within
that will
that
be
constraint of
nightmare.
40 minutes. Yeah.
Exactly.
I mean, I'm not able to understand that what Leon just mentioned, that how it actually we will combine these.
So, when we advance the slow pointer, right, and then we can reverse it at this. I mean, no, we advance the slow pointer one at a time. When we advance it, we can reverse, the first half at the same time.
Yeah, that is fine. I mean, up to that, we do have two lists, and the first one is the in the reverse order, and the second one is the original order. Now we have to combine these two, right?
Yeah. So, for example, in this example one, the first half we have to reverse will be 2 and 1, right? And the second half will be 3 and 2. I mean 3 and 4. We don't reverse it.
Yes.
Right. So now, we point our pointer to 2 and 3, right? We're gonna put like 2 and 3 first, right?
Okay. Yeah.
And then we advance to the next one. We have 1 and 4, right?
Yes.
Now we have 1 and 4. We put 1 and 4, right? And 4, the 4 would point to 2, right? So when we have 2 and 3, that is the result, right? The result so far,
so
right? Or the head
number
of the
one,
result.
Yeah. So one is that we have to. Okay. So we are combining, and let's say.
Yeah.
Okay. Can we take little bit big example where we have each list has at least 3 or 4 node?
Yeah, that would be kind of similar, but instead of appended to the end, we just prepend it to the head of the result.
So let's say we do have a list for 1, 2, 3, 4, 5, 6, 7, 8. So my list is 4, 3, 2, 1, and 5, 6, 7, 8, right?
Yeah. So.
Okay. Got it.
Yeah.
Got it. Thank you.
Yeah, we might have to give a more